Miss Gaither presented this project to us, and we were kind of like, oh, I don't know, cow dung.
We're trying to make methane gas for energy with cow dung.
But we thought about the useful applications of it and how it can really help other people in the real world, not just hypothetically.
Well, I was a Peace Corps volunteer in the village of Mabule in Botswana. The area is a very remote area in the southern Kalahari Desert. Cow dung, it's all over the place, and it's easy to gather. The idea is to collect the cow dung and to trap the methane gas and to use it as a source of fuel instead of having to rely on fire and firewood. Deforestation is happening, and when you look on the maps, you can see, people have to go further and further away to collect firewood.
And they also use propane gases, which they have to go all the way over here to South Africa to get the propane gas. It's a really small village that is located between the border of South Africa and Botswana. And I've been researching the vegetation and the climate. It has a really dry climate, and a lot of deforestation are happening, and people have to walk a really long distance to get wood for burning and using it as a fuel.
To help them utilize their resources, which are cattle, we said, okay, if we can get their dung and have them use the dung and ferment the dung to produce methane gas, then that would be something that doesn't cost anything, and they can generate it themselves.
We have the designs for what we're doing down. We're going to have a slurry of cow dung and water, 7 parts cow dung to 1 part water. Over the course of about 2 weeks, that's going to ferment and release gases, one of them being methane. The gases should go up through this tube and down into this inverted bottle, like this, inside of another one of these, that should push the gas in, push the water out. Once we're ready to use the gas, we'll open the clamp, which allows the water back into it, and the gas will be pushed out through the Bunsen burner, where we can light it and cook food or provide heat for anything they need.
As a class, we divided into 4 different groups, and there were 2 groups working on making a biodigester to break down the cow dung to generate methane gas for cooking and electricity and other power needs for the villages in Botswana. And then the other 2 groups were working on research on the area of Botswana and also on people who have done this before.
China is like an agriculture-based economy, and they benefit extensively by using biogas fuels and becoming more self-sufficient and reducing the load on using fossil fuels. So places that are more rural, that are trying to become more self-sufficient, need a method to do that.
Ukraine uses a system that holds 1,000 pounds of cow dung, and there's a process of how bacteria converts it to methane gas, which is transformed into energy. Since Botswana has high temperatures, it will do great. They will have a successful system like Ukraine.
I called Old Maryland Farm, and they gave me a whole barrel of cow dung, which I brought to school. I put it in a plastic container which was sealed, and that contained the smell. And we found out that it contained the smell because when we opened it, it was quite putrid.
Oh, that is so cool. More gas than last time.
Mm-hmm. Yeah. How long do you think it will take to produce enough?
A few more weeks. How much gas do you think it would collect if we left it over the summer?
I think we'd have to bring in more cow dung.
After a while, the gas will come out and come through this tube, and if we wanted to shut it off, we could just turn this valve, but we don't want to right now. Once the gas travels through this hose, it fills up the inverted bottle here, and once it's filled up a bit more than it is now, we'll hook this tube up to a Bunsen burner.
Whenever we decide to open this clamp here, we will be able to burn methane gas that we've collected, and we can use it for cooking, for anything that needs energy, which is pretty much a lot of the things we do every day. And so once we are able to produce this energy source and make it as efficient as possible, we'll be able to have a really good energy source for a place where renewable energy is very limited.
Right now, as the cow dung is fermenting, the gases that are being produced are hydrogen sulfide, CH4 is methane, and then CO2, so it's carbon dioxide. And right now, all we want is CH4 to create like the gas and the energy to use to like burn fuels and stuff like that. So when we're going to collect the gas, we're just going to collect the CH4.
So as the gas enters into this, so this tube's open. So as it enters into this, there's water in the bottom. So as the pressure increases in here, the water should go up this tube, and we want it to be full of just the CH4 gas. And this is a closed valve. So then we have this exit tube, which we can put like a pipe or like anything that we want to come out, like to like put it into like a Bunsen burner or something. And then ideally you should be able to reuse the water, so you can just open this back up and then the water can come back down. So it's a reusable and like really easy, really simple way to harvest CH4.
I think it's really important for students to be working with renewable energy sources, especially ones that aren't really tried large scale yet, because it introduces us to concepts of the future.
Working on a project like this, like producing renewable resource like gas, is helpful in a way that's realistic. It's not just a project where we see something happen and then just let it go, but it's something that we can actually use for the future.
We often talk about renewable resources. Here's an actual project where the students are actually being part of a process that can benefit another country.
And it can improve the overall health of them, not ingesting the CO2 from burning wood, and preventing deforestation. So overall it's a positive thing, and it keeps a small village running without having to spend too much money.